much. I think the is the mic on? Testing. Are any of them on? There we go. Thank you for the introduction. We have our next panel right now, which is space-based solar power. And similar to last year, what we'll be doing is essentially have a debate. We're going to make it lively, entertaining, edgy. There'll be everything devoid of personal insults, but things coming close to that.
Why?
So over the next hour and 15 minutes, you'll hear statements, facts, hopefully, and opinions regarding why space-based solar power is a viable solution to meeting our energy demands. And you'll hear some skepticism as well. So before we get started, I thought we would provide a little bit overview on why this discussion is important. Space-based solar power is a very cool technology. We all, as space advocates and proponents of space activities, definitely view space-based solar power as I think, in the future, a utopian principle. Meaning, one day there may be space-based solar power satellites orbiting the Earth, providing the vast majority of electricity that we would require here on Earth, and without any emissions in a clean and renewable fashion. Definitely a positive outlook. However, there are many issues associated with that, and let's jump into that. Before we get started, my name is Amrish Kalapara. I do know most of you in the audience. I'm a business consultant and financial analyst to several NewSpace companies, and I'm also co-founder and managing partner of a company called Earth to Orbit. And what we do is we launch small satellites by partnering with the Indian Space Agency, and we also are a technology commercialization arm to several Indian entities. I will have our distinguished panelists also introduce themselves as we proceed through the day today. So here's how we're going to do this. I'll be the moderator. In the blue corner, proponents, we'll have Taylor Dinnerman and Feng Shu. And in the red corner, we'll have Joe Carroll and Tom Olson, being the skeptics. Our premise that we're trying to debate today is the statement you see at the top of the slide. Space-based solar power will become a viable solution to address the growing energy need or growing energy demand within the next 50 years. Proponents will be saying that, yes, that is true, and skeptics will, of course, will hopefully say that that is not true. Here's some background. Why is this argument important? We are now experiencing probably the greatest acceleration of energy demand in the world that has ever been experienced in history. Right now, current estimates show that world demand for electricity will double in the next 20 years. Double. Most of this growth is being funneled through India and China. There's a slide representing Indian electricity demand, quadrupling in the next 20 years. China doubling in the next 20 years. The United States, the demand curve doesn't look that high, but it represents a 40% growth in electricity demand over the next 20 years. What does this mean? Well, it's got serious implications on where we get energy from, how we do it. Can we do it in a sustainable way? Will we run out of resources? Can we do it in a clean and efficient manner that won't affect climate change? Will nations around the world be competing for natural resources? So all these questions I think are at the top of our minds as we engage this discussion about space-based solar power. How does space-based solar power can it coexist with the other forms of electricity generation today? So this graph shows roughly 2/3 of global electricity production is produced using fossil fuels: coal, natural gas, and oil derivatives like diesel. The remaining is mainly made up of hydro and nuclear. The small sliver you see there is essentially everything else: solar, wind, biomass, biofuel, anything you can think of. Wood chip burning is less than 2%. So given this, what can space-based solar power do, and why should we be worried about it? So two parting facts before we move on to our actual debate. There are two pressing issues that I think will come up in the debate today. One is, obviously, energy demand is growing exponentially in several areas around the world. Two, resources are running out. There are several studies that show in the US itself we have about 100 years of coal left and possibly about 100 years of oil left. Those and 140 years of natural gas left. Those three things represent 2/3 of our electricity production in our country today. So what happens when they run out? What are we going to do? How do we meet demand? China right now is the number one explorer of natural resources in Africa right now. They are investing amounts of money that no one has ever done before in investing in oil fields, coal mining, and uranium production in Africa. Is there a future conflict for natural resources for electricity production? Who knows? So let's jump right in. Let's go to our debate. We're going to do this very strictly according to time. Each team will have 5 minutes each to opening arguments, and then we'll proceed into technology considerations and economic considerations, and then each team will have closing argument time as well. So with that, let me bring up my trusty stopwatch, and we will start with the proponents, the advocates of space-based solar power. You have 5 minutes, Taylor and Feng. And before you start, please provide a very brief background and introduction to yourselves. And you have 5 minutes to discuss your opening arguments on why SBSP is viable.
Okay, thanks, Amaresh. Hi, everyone. I'm Taylor Dinnerman. I'm currently a senior editor at the Hudson Institute, New York. And I'm also a consultant to Space Energy, which is a startup solar power company. Feng also works for the same outfit. And space solar power has been an interest of mine since, I would say, the mid-'70s, when I first read the Gerard O'Neill space colonization study, which later emerged into the High Frontier book that we all swore an oath on last night. And I think that space solar power is one of those technologies that is a true civilizational game changer. It hasn't emerged because of launch costs and capital costs, and because so far the costs of fossil fuels has remained relatively affordable, with spikes to unaffordability in the summer of 2008, when oil went up to about $148 a barrel. It inflicted major economic damage on the world, and I believe that this provided a new impetus for people thinking about alternative energies, though they naturally fell back on the solar and wind solutions, or terrestrial solar and wind solutions, which I believe are not viable. And the demand question for electricity is what is driving this debate, and I believe will drive the demand for space-based solar power over the next 50 years. I believe also that the demand is maybe understated. I think there are new technologies emerging, such as household robotics and medical robotics, which are going to drive the demand for electricity much higher than we currently expect. I think that, well, the numbers that Amaresh showed for India and China, I believe, are quite accurate. I believe there are other places, such as Africa, whose demand curves are going to be similar to those of China and India over the next 50 years, probably beginning in about 10 to 15 years. And so everything that we have, gas, coal, oil, hydro, nuclear, is just not going to match the demand. The one place that we can go, aside from a notional fusion reactor, which I don't see on the horizon anytime soon, is space-based solar. Now, whether space-based solar is feasible at the price points that are affordable is, of course, the critical question for the business case. And this is where a number of companies, ours and in California, Solaron, have been signing these power purchase agreements with various utilities. And these power purchase agreements promise to deliver space-based solar power at X price, which is usually slightly above current costs of hydrocarbon-based fuels. Now, these companies will either meet these prices or they will not meet these prices and thus not get paid and thus not make any money, and that is a bad thing. And so the companies are making these bets that they can deliver at these prices, and this is why this motivates them very strongly to get it right. Now, I'll hand it over to Feng, who can speak more competently than I can about the price problem.
Feng, you have about 2 minutes.
Hello. Yeah, my name is Feng Su. With Space Energy, I'm a Senior VP of Engineering for Space Energy Group. And my background, I've been working for many years at Brookhaven National Lab. So I become from nuclear engineering and to aerospace engineer. And later, NASA, ever since 2000, moved to NASA, work on the shuttle program. And so interest shifting from nuclear. I was a nuclear actually strong advocate for nuclear energy. So I was at Brookhaven, one of the major DOE laboratory for nuclear reactor study, safety study. And later on, I gradually become, I think nuclear probably is not the sustainable solution for the, I think space-based solar power has a great potential. It's one of those typical technology we heard about those days. So game-changing technology or cross-cutting technology. From, if you see from any aspect of this concept, I just think you cannot go wrong if humanity head in that direction. Just basically, I have three fundamental arguments that say the space energy is not. It's a promising approach. I'm not saying guaranteed will produce the base load and the cheapest energy on Earth, but has three fundamental principles that we should think about when we think about why we need to start developing this technology. One is the fundamental resource of the energy that human beings rely on Earth is the energy from the sun. The solar energy is our fundamental energy in our solar system. So on this planet, actually, everything comes from the sun. I wrote an article years ago, harnessing the sun is the next giant leap for humanity. So if you think about it, the efficiency, people argue there's an efficiency, cost reason, economic reason. But that's fine, that can change. But fundamentally, if we keep digging, looking for resources beneath the surface of the Earth, that's limited. But if you go after the original source of the energy, which is the solar energy, and everything, including fossil and everything on Earth, the coal, petroleum, everything, actually originally come from the energy from the sun. So my argument is to just bypass the solar energy to fossil inefficiency, go directly to the sun, go to the original energy source. That's already a big shortcut. So according to assessment and calculation, so my technical background basically is a technical background. So I did some calculation. I'm not going to give you detailed numbers, but the efficiency of any other fossil resources, including coal, gas, and petroleum, everything is very inefficient actually. So the solar energy, based on the study, the NASA DOE Boeing study did back in the late 70s, Overall, you have if you launch solar power satellite and collecting energy from Earth's orbit, and you will have overall around about 12% total efficiency. That's way above any other terrestrial energy source that we're getting from coal or oil or gas. Because nuclear is about 1% efficiency. So my point is first principle, go directly to the original source. Human being will not go wrong with that approach. Secondly,
can I ask you to wrap that point up and move on?
Very quickly,
more time than
very quickly, the demand. The second principle is demand. The demand is increasing rapidly. So we have heard Taylor said that China has overtaken U.S. for the last 30 years of development with 1.3 billion and an increase in population. So sooner or later we're going to have to deal the energy problem. So instead of conflict is not an option. So we better to look for. And
I'm going to have to cut you there, Tim.
I'm
sorry. No, we'll have plenty of time later on.
Make another third principle.
Okay. So now we'll have 5 minutes of opening arguments for the skeptics, Tom and Joe. Go ahead.
Okay, great.
Already tied in knots.
Yeah. My name's Tom Olson. I'm the managing partner of Exodus Consulting Group based out of New York. We do business development and financial consulting to both the services industry and to companies coming up trying to raise capital. And we help them with their business planning. 60 or so years ago, when the first nuclear plants were being built in this country, the proponents of building lots and lots of nuclear plants used to say that the power generated would be so plentiful, it'd be one day be too cheap to meter. And I'm hearing in many ways that same argument kind of crop up again in the solar power arguments that I see. Someone, an engineer, actually approached me at ISDC last year and said, "Hey, Tom, I got the cost down for the whole program to $50 billion, and we're going to deliver power at 2 cents a kilowatt." And they say the giggle factor isn't dead. There are wider problems involved in just energy supplies and energy demands. We've got a lot of other things going on. And while we like to think in global terms, we're not one global world where we all have an equal influence. I can't tell China what to do with its coal any more than they can tell us what to do with our nuclear plants, or any of us can tell Australia what to do with their uranium supplies. And demand curves are going to be very different going from industrialized to less industrialized countries, and we have to take that into account. All we can control through these policy discussions in this room is, what can America do? I know everyone will probably expect us to take the lead somehow in this, and really, can we fiscally do it? And for the kind of power generation that I've been hearing about and that we've been talking about, you're talking about building something 10, 20 times the size of the ISS, and you're going to have to do it at a fraction of the cost, using 20 times the labor force, if not more. There are all sorts of other issues to be considered. I mean, I don't know even if $100 a pound to LEO is going to cut it. Where does the money come from to pay for a program that size? I would posit that in terms of getting out of the bubble that we like to live in for 4 days a year, the country's broke. We have a $60 to $70 trillion entitlement time bomb that's we're going to start banging into very, very quickly. That's the equivalent of $60 to $70 trillion asteroids, if you're a member of that particular religious sect. And how are we going to get that, and where does it come from? And there are only 3 ways that projects of that scale can be funded. Is usually through government, and it's usually either through taxation or borrowing, or just printing up the money. And so sooner or later, all that extra money is going to trickle down into the economy, and you'll find that things cost a lot more than they used to. And we may not have the constituency big enough to make that happen. There are already 40 million people on food stamps this year, and it's expected to go up to 43 million. There are other types of time bombs that are already going off all around us, and we need to start paying attention to them. One of the downsides of the global economy is that we're now American workers are now in direct competition with workers in China who are making 85 cents an hour and have no benefits. The middle class is shrinking rapidly, and it's becoming just this, again, this ticking time bomb that we have to look at rather than look at just the specifics of space solar power. I love the engineering. I've always been a big fan of it. It's just the coolest thing ever. I have been a big fan of it since I read that book in the mid-'70s and was one of the original members of the L5 Society that proposed this thing. The economics of it don't impress me at all, and the more I look at these plans and try to make it economically viable, it is one thing to build a huge structure in space. It's another thing to try to run or work with a major utility company. One of the I'll make one last point. At the original Space Investment Summit 3 years ago, there was an institutional capital group made a presentation, and they did their own analysis. If it was done with private capital, what they would have to charge just to make their money back in even an unreasonable time frame, like 20 years or 30 years or something. And they said it'd be 85 cents a kilowatt. This at a time when off-peak in New Mexico was 4.9. I think we still have a long ways to go. Yes, I do think someday, by mid-century, there will be space solar power satellites ringing the globe. That globe will probably be the moon or Mars. And there's whole other reasons for doing that that actually make sense. But as far as a major economic solution that's actually going to replace fossil fuels, which the proponents have always said they would do, I'm not seeing it.
I'm Joe Carroll, and I feel extremely awkward being an opponent of any space technology because I've sat in that seat so often in the last 25 years, okay? But I was actually thinking back about one particular incident where I ran up against a skeptic, and that skeptic was Aaron Cohen, and I was telling him about space stations based on external tanks. And he made a very interesting comment that probably saved me 5 years of my engineering life, okay? He said, space stations aren't mostly about habitable volume. They're about the stuff that goes inside that makes it habitable and useful. And that made me realize that external tanks were a very small part of the problem, and they bring their own idiosyncrasies, highly outgassing materials on the outside, and a lot of on-orbit construction, order of magnitude more than maybe ISS would require. So I benefited from that skeptic, okay? And I'd like to provide a skepticism that may be equally useful to you. There is a major market for power in space, generated in space with solar energy and used in space, ComSats and GEO. It's a very big business. The allowable cost of the hardware is several $100s a watt before launch and before integration of the cells into arrays in launch. Terrestrial solar cells cost about 1% as much. Now, yes, you've got full sun, no cloudy days, no night, but that's compared to the ground a factor of 5 for the best ground-based sites and 20 for maybe a pretty bad one. I don't see where the factor of 100 is going to come in. You can reduce costs somewhat, but it seems to me that if you have all the smart people working in your project and none working on flying windmills and offshore wind and other things, you'll win. But that you're not going to be lucky enough to have that. And so that's the challenge is that there are lots of terrestrial alternatives. The world's electric power needs could be met with moderate efficiency solar cells covering Nevada. Okay, and that's including growth, the expected growth over the next 20 years. That's the world's, not the US. So the real challenge I would ask all of you and you to think of is if you're going to ask the US government to invest in this, would you invest your own money? Because it is really yours and everybody else's money. Is it the best investment? It may not be a bad investment, but is it the best investment in new energy sources? And I'm very skeptical there.
Thanks, Joe. Let's move on. So now we're going to begin the technology discussion, and we're going to start with Feng and Taylor. And remember, as we discuss this, please keep the premise in mind that space-based solar power will be a viable solution to the world's energy demand in the next 50 years. So think through that as you discuss the latest developments in technology and any discussion around technology you want to bring up that leads to that premise. 5 minutes, and I'll be less generous in the 5 minutes this time around.
Okay. Well, first of all, have to say that government money is going to be involved, but in various secondary ways, mostly through technology, providing technology that already exists to the space solar power industry. Direct government investment is not a good idea for any number of reasons, many of which have been discussed here and in other places. The government has not done such a good job of running things like, well, TVA and so on, and we can also discuss General Motors and all that fun stuff. But the private sector has a huge unallocated amount of capital. I mean, there are literally trillions of dollars that are sitting idle right now in various investment funds that are not being invested because of uncertainties and so on, and I think that's part of it. Now, as far as the technology goes, the technology has been improving for terrestrial solar cells, and every time it improves for terrestrial solar cells, it also improves for space solar cells. That is just, so the advantages accrue to both sets of
The offset of 100 remains.
Yeah, the offset remain. Yeah, and the advantages remain. And the other thing is that we are slowly and painfully slowly beginning to reduce launch costs, and this is something that we're seeing with Falcon 9. And I think the fact that Falcon 9 just won a major launch contract from Iridium, then they took it away from the French and the Russians, is a major factor in showing that launch costs can be reduced and are going to be reduced over time. And so I think with those things, and also the new materials, and the new materials that are coming along, such as carbon nanotube structures, are going to reduce both launch costs and the costs and weights of putting large structures into low Earth orbit. And there are other technologies that are coming along, particularly thinking of stuff that Ivan Becky has been doing with bimorph structures, things like that. And so the technology is moving in the right direction. Now, whether it's going to get there in 10 years or 15 years or 20 years is, that's all open to question. We don't...
2 minutes.
Thanks. So just hand it over to Feng, who can also discuss some of these technological issues.
Yeah, let me summarize. I want to respond to Tom and Joe. Basically, their argument against Tom is, first of all, the nuclear, people, when they're promoting nuclear energy, they said, they're so abundant you don't even do metering. I remember those. So we had that unrealized sort of a dream. So here's again, we cannot move on to work on the other thing. That's one of his argument. Another argument, Tom says that basically the country is in financial trouble. We are broke. We cannot spend any money. We better do something currently cheap or existing technology. And Joe's argument basically is, how can you get a cost of transportation done? He doesn't see the economics.
No, not the cost of transportation, the cost of the cells.
Cost of cell, the overall cost. So you don't believe there's a cost, the cost can be competitive. So my argument that in my first 5 minutes, I forgot 3 principles, and going directly to the original source. And there's a huge demand, unavoidable, inevitable demand. We have the crisis, energy crisis we have to address. Another one is innovation, game-changing technology. So those, if you follow, and also Joe had another argument. He doesn't think there's a lot of other options. There's one of the options is not the best option. But my argument is, yes, nuclear, we had 40 years, actually. That's why I become not a nuclear proponent anymore, because we had 40 years and we didn't really solve the energy problem crisis. And the nuclear fuel, the uranium ore deposit on Earth is limited. So that if you remember early 1990s, the uranium fuel cost more than order of magnitude higher right now. So it's limited. So nuclear, because of the nuclear had a bad experience, that doesn't mean there's another new concept that we cannot pursue on. Of course, there's a lot of argument with. I don't have time, because nuclear was the key industry actually prevented some of the early phase of RD study on the space-based solar power, according to late 1970 report. So, and also another argument is the country's broke, yeah, because the third principle I'm arguing to a proponent of space-based solar power is it's one of the most conceivable game-changing technology. And not just game-changing, but cross-cutting technology that can change the whole economic dynamics. So this is something human being worth for us to pursue, to invest on. Also, about the economics, so you cannot really estimate or calculate economics, because this is a game-changing technology. It's something, there's no fundamental theoretical barrier or impediment for human being to develop, but there's no physics, no theoretical obstacles that prevent us from getting it done. But the economics always an easy problem to solve. If you invest, if you have the leadership, have the policy, human ingenuity is unlimited. We were early 1960s, nobody would believe we spent, at that time, Kennedy said we would spend 10 years go to the moon, and we spent less than 8 years. And went to the moon. Nobody believed, that the Apollo project would be successful.
I think I'm going to have to stop you there. Thank you. So, Tom and Joe, 5 minutes, please. And we're trying to keep it to a technology discussion. We'll move on to other economic issues later.
Yeah. In the area of technology, you say that human ingenuity is unlimited. I agree. That could have been used many years ago to argue that the U.S. should have spent a huge amount of money on slightly cheaper mainframe computers, based on the fact that that was clearly a feasible goal. And we would have missed the microcomputer revolution, probably, okay? You are assuming that a disproportionate amount of the creativity is a river running your way. And that's the least predictable thing around. I'd like to make a distinction. It is said that the most perishable commodity in the world is an airplane seat, commercial airplane seat, because it goes from its maximum value to 0 when the door closes, okay? Now, to a certain extent, electric power fits that, but not perfectly, because there are different degrees of storability, seconds to minutes to days to seasonal, depending on what the overall mix is. And so, for example, desert-based solar power is great for summer afternoon, but it's lousy for winter evenings in the Northeast, okay? Wind is great for winter evenings in the Northeast. But there are times when you don't have either, so you need something else. Well, there's a certain amount of hydro capacity. To really look at the value, I mean, power seems like the ultimate commodity. A kilowatt hour is a kilowatt hour. But even in the terrestrial civil market, that's not true. I mean, you're very interested in the military forward power. The bigger fungibility issue is the civil terrestrial market. Okay, and you really have to look at what are you displacing and how valuable is it to displace that. And when you have a mix of new technologies, some of which can be foreseen, some of which cannot, you have to fit into that, or you have to take over the debate by being cheaper than all of them all of the time. That's not going to occur. And so, for example, it may be that with terrestrial solar, which gets cheaper but doesn't meet the mix, that it hits the daytime peak and you're not selling your power for very much. because what used to be the needle peak is now the low marginal demand case because there's so much terrestrial. So you really have to envision yourself as part of an ecology and make sure that you're competitive at each time. That's hard.
It's kind of an irony, an example of how technology development and deployment is such a moving target and such a rapidly changing world. And the irony was, when I was in my hotel room this weekend, there was this magazine sitting there. It's supposed to be like a home design kind of magazine, but they had this whole article in the back of this extremely energy self-sufficient homes they were building in Denmark as a test project, and they were so efficient, not only would the homes essentially pay for themselves, but all the energy used to create them as well would be essentially paid for through the cost savings and self-generation of power and thermal solar heating and passive and active and all the other things that were built into this thing from the ground up. We're in the industrialized Western world, at least, I expect to see millions and millions more of similar projects and developments coming across both Europe and the Americas in the coming 4 decades, as well as a lot of great improvements in other types of passive and active solar systems. As of right now, there are at least 3 companies I could mention, Solindra, First Solar, and Nano Solar, all of which have either raised tens to hundreds of millions of dollars to create their technologies. First Solar in particular has actually done an IPO. They've had purchase agreements for 2.2 gigawatts of utility-scale solar development capacity in North America. They're going to be building out somewhere near Yuma, and they've got, as of a couple years ago, they had about a $20 billion market cap. Now that's real money being put into real terrestrial systems, and they're able to move more nimbly in their development cycle. And if you're not careful, they're going to pass you by.
Yeah, that's exactly 5 minutes. Thank you. What we're going to do next is because some folks didn't stick to the prescribed outline that well. That was supposed to be a technology discussion. Let's move on to economics. Now, what we're going to do here is we're going to go 5 minutes back and forth twice. So each side will get a total of 10 minutes. And economics has always been a major issue in discussions regarding space-based solar power. Just some background. When electricity is sold, obviously it's sold at the kilowatt hour level. That's the packet of energy that's usually sold. And average prices in the US fluctuate around a little less than 10 cents. Coal power is about 5. Nuclear can be around 7. If you factor in transmission distribution costs, terrestrial solar is about 12 to 15. What this discussion should center on is how does a kilowatt hour developed from space-based solar power compare to the other options? Not only the
price in PG&E in Pacifica is 44 cents a kilowatt hour.
that's Pacifica.
You only need one market. You don't have to rule the world. You have to find one niche.
So, well, that's what the panel is going to discuss, was do those niche markets that can command a 44 cent or a 50 cent, or the DoD that can command well over $1 a kilowatt hour, does that close the business case? And is that sufficient to move space-based solar power forward? Consider that, and also consider the installation costs. A average coal plant, less than $1 billion for a gigawatt of capacity. The average nuclear plant, if they were being built, $10 billion per gigawatt of capacity. How do those compare with space-based solar power? And how do we compare apples to apples in this discussion? So, economic considerations, we'll start with Feng and Taylor. Can you discuss in your arguments, how can we compare space-based solar power to the other options out there? And is that an appropriate comparison? And talk about the niche markets that people mentioned in the audience.
Well, I'd like to bring up Denmark, since Tom brought that up, and I have some good reasons to be interested in Denmark. Denmark is a very interesting case because they have been pushing the idea of that the whole nation is going to become as green as possible, and the whole nation is going to be based on renewable energy. And currently, to buy something like a absolutely very basic vehicle like a Volkswagen Jetta or something like that, it's $70,000 to $80,000. So they are building this economy in a forced march way. So yes, their houses, their ecologically correct houses may be interesting, but they're done at a cost of that we may not want to pay in this country. I like to think so. But the point is that we have a demand. The niche markets are what may drive the first elements. Now, some of the niche markets, the military market is a very interesting one because the military, of course, has all the reasons that we saw in the National Security Space Office study. They have enormous demand for electricity in remote bases that may not last, but it's going to be a constant demand for a while to come, and they are going to want that demand, that supply, to be on standby, so they'll have it when they need it in future operations. So the military will not only pay for the space-based solar power supplies now, but they will be very happy to subsidize it or to have it on some sort of standby agreement, similar to what they have with the Civil Reserve aircraft fleet. And that will provide at least a foot-in-the-door market for space-based solar power. It's one of the items. The other item that is going to drive this internationally is the inland nations, and this is where Africa comes in, because inland nations in Africa have been suffering for decades because they have to import fossil fuels through nations that have ports and coastlines, and these do not always are not always friendly. So nations like Uganda, Rwanda have serious energy problems, serious energy costs, and for them, space-based solar power would be a godsend. Now, the other...
2 minutes left.
Okay. The other thing that I want to get at with the requirements is we have always managed to find innovative ways of getting around problems. It's in America, we like to think that we can make anything work. Now, whether it's going to be wind power or terrestrial solar, it's great. I think we need all of the above, and there are going to be a lot of smart people working on wind power and working on terrestrial solar. And there's a lot of people working on the transmission problem, which is another problem. But the space-based solar power provides baseload power, similar to a nuclear power plant or to a coal plant, unlike the intermittent power that comes from terrestrial solar or wind power. And that's where the long-term demand is going to come in. The other thing is terrestrial solar or space-based solar is just part of the ultimate solution in 2050. There's not going to be any one solution, so sorry.
And Feng, before you start, can you comment on what a space-based solar power satellite will cost at any given size? You can select the size you would like, and then talk about how this compares to other options.
Yeah, the question actually cornered my thought into a box. You want me to compare with a lot of assumptions of the current launch cost and current PV efficiency and the current technology.
Or if it's not a valid comparison, you can say why it's not valid as well.
Yeah, but I'll give you a figure. Based on the late 1970, NASA Boeing DOE study, supported study, we spent like more more than $20 million on that study. And there was a report coming out, basically 1 gigawatt, calculate the number of 1 gigawatt of whole system, including the satellite. That study was a 5 gigawatt, but I used the comparison with the nuclear. 1 gigawatt is normally nuclear power plant capacity. You have about approximately $12 billion per system. That's including the ground rectangle system, including the space system, including the transportation at that time. But a nuclear power plant, or a typical 1 gigawatt power plant, we know right now it probably costs about that, or if not more than that. So, but to talk about economics comparison, we talk about risk-benefit-based decision-making, options, alternatives. So when we talk about that, we have to, not just when you're making decisions, because I was one of the decision-making, MIT, NASA decision-making methodology core team. I'm a team lead. We're making decisions, when I was in NASA Goddard, we're making decisions on issues, and one of the, we call the OSWIC working group, and exploration, what we're going to do on the moon. So those are very complex decision issues. But when you talk about that, you cannot just look at the economics. You have to look at so what's your benefits, what's your risk, compare with the other options. So because it's unacceptable in my view for the United States government to not invest the 1 penny so far, at least for the last 10, 20 years, is absolutely unacceptable. We're not advocating, say, tomorrow or next 10 years, 5 years, we're going to create this huge, gigantic government system and a space called the space solar power satellite, and we'll solve half of your, or 90% of your baseload electricity problem. We are comparing any other NASA investment so far. So my view is investing on such technology like we call the cross-cutting right now. Typical cross-cutting technology like a space solar power, there's very little risk you can go wrong economically, politically, technologically, because there's lots of spin-off technologies were coming out of it. Because the economics doesn't add up right now, it's because we don't have the market. So human space tourism and space solar power are the two big most drivers that will drive down will create the market for demand for launch, will drive down the launch cost. And we're bringing up the reusable technology, the NASA explores, everything is going to need it.
Okay. Thank you, Feng. Joe and Tom, 5 minutes, please. Economic considerations.
Yeah. You mentioned the forward military issue. The GPS system was developed essentially with one requirement. I've heard it described as 5 bombs in 1 crater. That accuracy has not yet been used as a driver for precision air delivery of supplies. I mean, it's a natural thing. If you can put a bomb precisely somewhere, why can't you deliver a fuel bladder? They have had such a program, APADS, GPADS, all sorts of things. The total amount spent on them is very low. The allowable cost of the system has been a silver bullet kind of solution. The military probably has maybe a dozen or 2 individual units. I mean, not like copies of the same bullet. The investment to date is probably something of order in the precision air delivery, airdrop, is probably something of order 0.001% of DOD's budget for 1 year. So I mean, a few minutes worth of investment of the DOD budget. I think that if you multiply that by a factor of 10 and make it an hour's worth of the DOD budget, the market for forward power goes away entirely. Okay. Again, the big challenge with economics is you have to have all the smart people and the other people don't. It's a real gamble on new technology no matter what you do, and my concern is that it's a technical and economic question. What is the gamble for my idea versus another idea? And on the space-to-space application, you have to sell your power beaming based on a difference in value of power generated on board versus power generated remotely. In some cases, that is high. If you've got a lunar polar facility, yeah, and it's got 2 weeks of no sun, whatever. But realistically, there are other options even there, and power use in space is a distinctly different thing. I can be very bullish on that and be skeptical of power beaming for profit, okay? I think that even the space power beaming is something. I'll give you one potential market. I'm skeptical about the space elevator, okay? This is a seat that I would be on this side if this were the space elevator conference. But we always assume that the power is going to be beamed up. It may also be beamed down, okay? That could be an application. It does require laser rather than the RF. And actually, we didn't get into this, but I would like to see more discussion of laser. But I would also like to see a recognition that when people say, oh, it's not a weapon, it's not a weapon just like a garbage truck is not a weapon. It's because you have a contract to collect garbage, and if you start running errands for the mafia, your company loses its contract. That's why a garbage truck is not a weapon, okay? A laser-equipped and maybe even an RF-equipped solar power satellite is a weapon if it is used as a weapon, and it can be. It is not.
2 minutes left, Joe.
You have a situation similar to that of garbage truck operations.
Again, from an economics point of view, my biggest concern, and probably your biggest challenge, throw that out there, is whether or not develop certain niche markets for your product, but whether you can break out of those niche markets into something much larger and scalable and economically sustainable, and to say that we owe it to ourselves, we have some kind of moral duty or something to build these giant, huge plants, even if we have to subsidize the power that comes out of them in perpetuity, is extremely disingenuous. Sooner or later, these things have to pay for themselves. I'm just not seeing the plan that gets us there. I don't think there's been, I'm looking at people's business plans, I don't just have to look at the technology, which is lovely. I've said this before. I have to look at the entire picture of how it gets there, how it's built, how it's going to be sustained, who's going to repair it, how are you going to protect those people, and for how long, and what's the operational life of something like that? And then how do you stand it down when it's lived past its operational life? And what do we do to recycle it at the end? All of those costs are going to have to be factored in. One simple little thing that underscores, I think, the point. In 2006, either the sun had a hiccup or something else happened, and there was a brief little glitch in the Earth's magnetic field, and as a result of that, it caused the residents of the ISS at the time to have to go into a more specially protected area for a while until that problem passed. The Earth's magnetic field does have these fluctuations. More are expected in the future, and that raises the question of how well protected are these systems if the Earth's magnetic field fluctuates and all of a sudden you're exposed to the full force and full faith and credit of solar radiation at all spectra, and what it's going to do to those things and what it's going to cost you to maintain and repair them and protect the people that might be actually up there doing maintenance work. Hopefully a lot of it will be robots, but sooner or later somebody's going to have to come up there and repair the robots, and you got to factor that in.
Thank you, Tom. We're running a bit short on time, so I think I'm going to try to take the panel in a different direction. We're going to have one more 5-minute session, so 5 minutes for each side. And I'd like you to address in these 5 minutes, if you can, 2 points. One is, yes, space-based solar power is extremely difficult. I think we all know that. It's expensive, and there's some technology obstacles as well. And it's going to require a coordinated effort from commercial industry and maybe some government involvement. That government involvement may be money, or it may be policy considerations. What is the path forward? How do we bring this to fruition? How do we make it viable? So we're going to start with the proponents. Comment on where we go from here. And the skeptics, comment on why you think the plan forward is not doable. So that's point number one. Point number 2 is, let's go back to our energy mix slide. Right now, all global electricity is derived from these sources you see on the slide at those proportions. In 50 years from now, if space-based solar power is not viable and doesn't work, where are we going to get our energy from in 50 years? What will that pie chart look like in 50 years if we don't have SBSP? If we do have SBSP, what will that pie chart look like? So those two concepts. What does that look like in 50 years with or without SBSP? And the first one is, where do we go from here? So I'll give Fang and Taylor 5 minutes. And this is essentially going to be your last 5-minute hurrah. Because after this, we'll try to get some audience participation as well.
Okay, Fang, why don't you start?
Yeah, 50 years from now, I think that pie chart, we know nuclear is not going to make it, right? Because it's just the uranium fuel costs are going to go through the roof. And nuclear fusion, which the U.S. government and other governments around the world spend, hundreds of millions of dollars every year. We spend 50 years. And likelihood, I'm an expert on risk assessment. And trust me, I built a shadow risk model. The next 50 years, the likelihood that we're going to see nuclear fusion become the major baseload power production methodology is very low, I tell you. And I'm not against any renewable terrestrial solar power. So most people on the side of the advocate of space solar power, and they have the argument, yeah, it's much, much better terrestrial solar. My argument is we're going after the original source of energy of the sun, including all the terrestrial solar technology. I'm all for it. I support it. But the economics will play its out. But also the government has to play a leading role, a major critical role to set up the policy to allow this cutting edge technology to thrive, to have a chance to become commercially viable. Why the government policy is so important? I always think the policies, like space solar power is a policy problem. It's not much of a technology problem. Because the government, and I'm a believer of free market, right? And if you just allow the free market to drive the technology development, and we're going to run into risk sooner or later, like 100 years ago, and we just discovered, by random chance, discovered the oil, and hundreds of years ago discovered the coal. But you just let the economic free market drive it, and that's where we drive almost the whole society economy into the wall. We have a crisis after crisis. So the government has to play a leading role. What I'm trying to say, technologically going after the energy of the sun, why I'm so passionate to support space solar power, because it's in the right direction. I'm not saying guaranteed 20 years or 15 years now we're going to have space solar power replace everything, but investing in that right direction, we have to have the good technology drive economics. My argument, you cannot let the economics drive the technology, and then you're going to see all kinds of technology will create lots of environmental problem or even detrimental problem for human society.
So we have 2.5 minutes left. Taylor, maybe could you address where we go from here? Do we start with small demo projects? Do we get private financing? What are the steps to make this real?
Well, I think the private financing is going to be there to some extent. I'm not sure what just how big, but there are a lot of people who like the idea of investing in this sort of thing. But where we go from here, I mean, demonstrator projects, very interesting possibilities of using something like the Bigelow module as a construction shack for a demonstration project in low Earth orbit. That's one of the things that I like to think is possible. The other thing is terrestrial-based beaming experiments on a much larger scale than what John Mankins did in between Maui and the Big Island. Those are great projects. Then I think with a space-based demonstrator, using a very large antenna and getting the antenna technology right, that will unlock a lot of private investment that will allow for the construction of the first operational space-based solar power platform. What happens after that is probably a learning curve, people developing new models, and competition. People will try various inflatable concepts, such as the Solaron concept. I don't know what is going to be the exact nature of a successful space-based solar power operating model, but I think it's going to be there. One of the other things that is going to, we need to do is exactly what Tom brought up, is we need to understand the space environment. We need to look at solar flares, solar radiation, charged particles, all of the solar physics that can have an effect on space-based solar power systems. And we need to do it not just for space-based solar power systems, but for any large system that we're going to have running beyond low Earth orbit. And that's going to be good for the entire space industry.
That's 5 minutes. Thank you, Taylor. So the skeptics, two things. What does our energy breakout look like in 50 years with or without space-based solar power? And then the second thing is comment on their proposed path forward on how we make this real.
Okay, I'll take the first part. I think to understand what's going to happen 50 years in the future, it's good to look back 40 or 50 years. And the big word is tobacco. It took a hell of a long time to remove its political support, but it's still there, okay? Fossil fuels are the new tobacco. It is not at all an accident that the strategy for dealing with the threat of climate change and all this stuff is the same one adopted by tobacco, okay? In addition, the fossil fuel industry knows the regulators very well. It's got relationships with all of the state regulatory agencies that they deal with, and they have write-off rates that go out probably beyond 50 years. They're going to have to make changes, but they're still going to be a major player. I don't think they're going to be 60%, but they're probably going to be at least 40%. I think that there's going to be a shift towards natural gas because largely of its both availability and the lower carbon content per unit heat and the ability to burn it more cleanly and more efficiently. I think there will be some carbon sequestration associated with coal plants and stuff like that, but there will still be some coal plants in 50 years. I think everything else is going to increase in absolute and relative terms. I think the biggest increase will be terrestrial solar and other renewables. Again, I've mentioned I'm a fan of an engineer working on high altitude wind power. It's basically a kite that's a windmill. And it's very challenging, but I'd rather accept that challenge any day than the challenge of making the end-to-end solution work economically for space solar. I don't know nobody knows what the solution is going to be, but it's going to resemble today's in a fair amount in the advanced economies because of the current infrastructure and the rate at which they're allowed to write it off. The really interesting case is going to be the countries that don't have much infrastructure. There are cases now where the value of property in the boonies is related to the cost of stringing utilities. If you can be independent on power and have also eclipse of some sort, all of a sudden, living out in the middle of nowhere becomes much more viable. And the real value of decentralized alternative energy may be what it does to property values.
It's 2 minutes left, Joe.
Okay.
I'll try to be really quick about this. Just briefly, I just want to tell, I'll go to this real quickly, then tell a story how I got there. I see space solar still as kind of a sliver in the chart in the next 40 years or so. I don't think you're going to get past those niche markets right away. But there's a bone I'll throw you later on that one. What I see more is, again, a decentralization of energy delivery to especially the Western industrialized nations. If the internet has taught us anything, it has taught us that in terms of information flow, we are now all consumers and creators at the same time, and we will not settle for anything less ever again. And I think that horizontalization of information is going to be that theory, that paradigm is going to start carrying over to other sectors. And I will say that I think it's also going to carry over to energy. And as more of these local, low-cost, home-based solutions start becoming available, more and more as people's utility bills go up through cap and trade for whatever reason, people are going to start flocking to those solutions. Within the next 10 or 15 years, I'll say that people will be able to buy windmill kits or huge rolls of thin film solar at Home Depot, and they'll be rolling it out on their roofs, and they'll be putting things in their yards, and they'll hook it up as a weekend project in the afternoon, and they will be now contributors to the grid as well as drawing from the grid. And it'll start in the industrialized nations and it'll move out from there. As that stuff gets cheaper and easier to set up, you're going to see those things also being shipped around the world.
Okay, thank you, Tom. I thought we'd try to get some audience participation, and wow, we have a lot of questions. What I'd like to do is get one question for the proponents and one question for the skeptics. If we have more time, we'll do another cycle of that. So we have two eager gentlemen in the front. Al, go ahead, please. And we have a mic coming, so please use the mic and also phrase your question in the form of a question.
The Japanese solar sail that's out there has 5% of its area with
Sorry,
thin
who is
film.
this for? Proponents or skeptics?
Proponents. As thin film. And what that means is they're producing maybe 15–16% efficiency at a couple of grams per square meter. What does that do to the economics?
It's going to be revolutionary, absolutely revolutionary. If we can, that's why I'm not against any terrestrial solar or terrestrial wind, any renewable energy technology that the Earth-based. As far as it's renewable, it's not going against the wall. Basically, have unlimited sources. So that's a very good example. And one of the reasons we space energy want to make the business case because we have a partnership, and there's one university laboratory from Switzerland, and they have this new technology of a thin film. It's a radiation-proof kind of thin film technology at more than 20% efficiency. And I myself saw that a little panel. It's a very thin, and we call those are breakthrough technology. And if you have we call the specific power, one of the measure parameters of those thin film photovoltaic technology is a thin film that it's so light and so little mass that will have such a high efficiency. Each kilogram will generate 1,000 kilowatt or more, 1,000 watt or more energy. So those are breakthrough terrestrial technology you can actually use on the space. So I don't care which one comes to the winner, either space solar power or terrestrial solar power. But if you're going after original source, unlimited source, the government, we don't need any money from the government. But the government I cannot imagine the government, U.S. government, doesn't even say a word to support. And they keep saying any game-changing technology, cross-cutting technology. But this is typical game changer, have a potential to change the whole, not just the U.S. economy, strengthen U.S. leadership in technology development, but change the whole world, whole civilization. And we can't even say a word to support it. So once the U.S. government give a policy support, not even one penny, if they want to spend some money, yes, bring some of the element technology from TRL 1 to TRL 5 or 6. You will basically unleash the whole private sector, industry, financial, that the private sector is going to develop it. It's going to, we talk about space revolution. Space solar power technology, it has one of the big issue is they can, if you develop this technology, you will virtually develop the reusable launch vehicle. You will drive the launch cost down. It actually is one of the key driver will allow us to go really realize this space commerce and space revolution, human expansion into space. So there, to me, nothing can go wrong. Nothing can go wrong. Invest
Feng,
in this direction.
Let's wrap it up there, and we'll take. Thank you, Feng, for that answer. Let's take one question from the audience for the skeptics, and we also.
Break in with something that'll take 10 seconds. You mentioned a few grams per square meter. This is 2 grams per square meter. It's very useful to see what a material like this is like for handling. Okay.
Don't need lunch? It goes up by itself.
Yeah. Learning to handle these materials isn't art in itself that we're just at the beginning of, okay?
Okay, so one question, thank you, Joe. One question for the skeptics, and I think there's a gentleman in the back in the blue shirt that was waiting. Yeah, go ahead.
Sorry, this is maybe a bit of a pitch. I'm Tom Nogin from Laser Motive. I'm giving a lunch talk on a laser power beaming company. So there'll be lots of information in there. And I'm not sure if this is so much a question for the skeptics.
Please try to address it to the skeptics
right.
if you can.
Do you have any answers to the assertion by the proponents about nuclear power not being viable, given the development of things like TerraPower that's using nuclear waste to generate nuclear power?
I have various problems with that as a large-scale solution.
Use the mic.
Yeah. One of them is it's really hard to get enough people to go along with us when we say it's really good for us and our friends and really not good for North Korea and Iran. Okay? This is not a publicly discussed issue. It's just an awkward thing. It's thin ice that we tiptoe over, okay? And we have to deal with that kind of issue. If it's good for us, it's good for others. More generally, a big problem is that a large part of our defense budget is paid for in order to assure our access to fossil fuels that we get from overseas. I would like to see that budget paid for by a tax on those. It will help start untilting the playing field for everything else, including space solar.
Thank you, Joe. Well, I think we are out of time. Is that correct? Or do we have a few more minutes? No? Okay, I've been told we're out of time, but I'm sure the panel will stay outside during the networking session or during lunch. You can ask questions. Please join me in thanking our 4 panelists today. Hopefully the debate was valuable, and thank you for participating today. Thank you.
Not enough time.
Thank you. Thank you very much. I think the... is the mic on? Testing? Or any of them on? There we go. Thank you for the introduction. We have our next panel right now, which is space-based solar power. And similar to last year, what we'll be doing is essentially have a debate. We're going to make it lively, entertaining, edgy. There'll be everything devoid of personal insults, but things coming close to that.
Why?
So over the next hour and 15 minutes, you'll hear statements, facts, hopefully, and opinions regarding why space-based solar power is a viable solution to meeting our energy demands. And you'll hear some skepticism as well. So before we get started, I thought we would provide a little bit overview on why this discussion is important. Space-based solar power is a very cool technology. We all, as space advocates and proponents of space activities, definitely view space-based solar power as I think, in the future, a utopian principle. Meaning, one day there may be space-based solar power satellites orbiting the Earth, providing the vast majority of electricity that we would require here on Earth, and without any emissions in a clean and renewable. The remaining is mainly made up of hydro and nuclear. The small sliver you see there is essentially everything else: solar, wind, biomass, biofuel, anything you can think of. Wood chip burning is less than 2%. So given this, what can space-based solar power do, and why should we be worried about it? So 2 parting facts before we move on to our actual debate. There are 2 pressing issues that I think will come up in the debate today. One is, obviously, energy demand is growing exponentially in several areas around the world. 2, resources are running out. There are several studies that show in the US itself we have about 100 years of coal left and possibly about 100 years of oil left. Those and 140 years of natural gas left. Those three things represent 2/3 of our electricity production in our country today. So what happens when they run out? What are we going to do? How do we meet demand? China right now is the number one explorer of natural resources in Africa right now. They are investing amounts of money that no one has ever done before in investing in oil fields, coal mining, and uranium production in Africa. Is there a future conflict for natural resources for electricity production? Who knows? So let's jump right in. Let's go to our debate. We're going to do this very strictly according to time. Each team will have 5 minutes each to opening arguments, and then we'll proceed into technology considerations and economic considerations, and then each team will have closing argument time as well. So with that, let me bring up my trusty stopwatch, and we will start with the proponents, the advocates of space-based solar power. You have 5 minutes, Taylor and Feng. And before you start, please provide a very brief background and introduction to yourselves. And you have 5 minutes to discuss your opening arguments on why SBSP is viable.
Okay, thanks, Amaresh. Hi, everyone. I'm Taylor Dinnerman. I'm currently a senior editor at the Hudson Institute, New York. And I'm also a consultant to Space Energy, which is a startup solar power company. Feng also works for the same outfit. And space solar power has been an interest of mine since, I would say, the mid-'70s, when I first read the Gerard O'Neill space colonization study, which later emerged into the High Frontier book that we all swore an oath on last night.
Fashion. Definitely a positive outlook. However, there are many issues associated with that, and let's jump into that. Before we get started, my name is Amaresh Kalapara. I do know most of you in the audience. I'm a business consultant and financial analyst to several NewSpace companies, and I'm also co-founder and managing partner of a company called Earth to Orbit. And what we do is we launch small satellites by partnering with the Indian Space Agency, and we also are a technology commercialization arm to several Indian entities. I will have our distinguished panelists also introduce themselves as we proceed through the day today. So here's how we're going to do this. I'll be the moderator. In the blue corner, proponents, we'll have Taylor Dinnerman and Feng Shu. And in the red corner, we'll have Joe Carroll and Tom Olson, being the skeptics. Our premise that we're trying to debate today is the statement you see at the top of the slide. Space-based solar power will become a viable solution to address the growing energy need or growing energy demand within the next 50 years. Proponents will be saying that, yes, that is true, and skeptics will, of course, will hopefully say that that is not true. Here's some background. Why is this argument important? We are now experiencing probably the greatest acceleration of energy demand in the world that has ever been experienced in history. Right now, current estimates show that world demand for electricity will double in the next 20 years. Double. Most of this growth is being funneled through India and China. There's a slide representing Indian electricity demand, quadrupling in the next 20 years. China doubling in the next 20 years. The United States, the demand curve doesn't look that high, but it represents a 40% growth in electricity demand over the next 20 years. What does this mean? Well, it's got serious implications on where we get energy from, how we do it. Can we do it in a sustainable way? Will we run out of resources? Can we do it in a clean and efficient manner that won't affect climate change? Will nations around the world be competing for natural resources? So all these questions are, I think, at the top of our minds as we engage this discussion about space-based solar power. How does space-based solar power can it coexist with the other forms of electricity generation today? So this graph shows roughly 2/3 of global electricity production is produced using fossil fuels: coal, natural gas, and oil derivatives like diesel.